Today we're going to explain how to solve problems using trigonometric functions of special angles. A tool that we use for solving these problems is the unitary circle. It is a circle with center at point 0, 0 in the Cartesian plane with a radius of 1 unit. This circle will give us the coordinates that we need in order to solve these types of problems. The second tool we need to use are special angles, which are 0 degrees, 30, 45, 60 and 90 degrees. Trigonometric functions has a certain value depending on the angle they're at. For example, cosine of 90 degrees is 0 and sine of 90 degrees is 1. This is due to the value in the x and y axis respectively. We'll be able to replace these values into that equation. Now, there are some angles that will not be in the first quadrant of the Cartesian plane. For these angles, we use reference angles. As we said, some angles we will not find in the first quadrant, which is this one. All of the trigonometric functions are positive in this quadrant. Now, for the second quadrant, for example, only sine and cosecant are positive. So if sine and cosecant are positive in the second quadrant, then tangent and cotangent, as well as cosecant and secant, are negative in that quadrant. Then for the third quadrant, it's tangent and cotangent that are positive. And for the fourth quadrant, it's cosine and secant that are positive. We will find this in the following problems.
The first part of the operation is located in quadrant 2, which is negative. Then we find its supplementary angle, which is 60, and replace it in its original formula. Then, as you know, tangent equals to sine divided by cosine, which at the same time results in square root of 3 divided by 2 divided by 1 and divided by 2. Simplified into square root of 3 divided by 2 and simplified as square root of 3. Coordinates given by the unit circle. The second part, located in the quadrant 2 and positive, we do the same. We replace its supplementary angle, which is 30, and then we substitute it by the coordinate 1/2. The third one is located in quadrant number 2 and it's negative. This is already a supplementary angle and its coordinates are -1. After having all the values, we substitute them in the corresponding operations. Overall equals to 5.75.
This is the solution for problem 49. The equation that we need to solve is square sine of 225 minus square cosine of 270 plus square tangent of 60. We need to find the value using the special angles. For sine of 225 is located in the third quadrant, so the sign must be negative. The reference angle is 45. Now, using the table of special angles, we can see that the value of sine of 45 is square root of 2 over 2. Now, this is the answer for sine of 225, and we add a negative sign. Now, for cosine of 270, its reference angle is 90 degrees. Now, we look at the table, and the value is 0. For tangent of 60, tangent is equal to sine over cosine. So sine of 60 over cosine of 60 will give us tangent of 60. Now, the value of sine of 60 is square root of 3 over 2. And cosine of 60 equals 1/2. Then we solve this and it gives us square root of 3. Now, we substitute in the original equation. It is square root of 2 over 2 plus the square root of 0 and the square root of 3. Simplifying, we get 1/2 plus 3, which is 3.5.
I am going to explain this problem. We need to remember that to solve this problem, we will need to use the unitary circle. First of all, using our unitary circle, we are going to substitute the values of the problem to the values of the unitary circle. Then, we are going to solve for each value, and this is what we get. And we get the final result. that is 43 times the square root of 6 divided by 12.
This is problem 52. We need to find the values of cotangent of 135 degrees, the tangent of 60 degrees, and the sine of 180 degrees. For the first term, the cotangent is calculated by using the cosine and the sine. In this case, the reference angle is 45 degrees. Therefore, by taking the value from the unit circle, the result is 1. However, in the second quadrant, the cosine is negative, so that the final result is also negative. The second term is more simple, because the reference angle is 60 degrees. Using the definition of the tangent, we define the sine over the cosine, and the result is the square root of 3. In this case, the sine doesn't change, because the angle is in the first quadrant. For the final term, the reference angle is 0, and therefore the sine of 180 degrees is also 0. In this case, the sine doesn't change, because the angle is in the second quadrant, and still it doesn't matter because the value is 0. Finally, by substituting the terms in the expression, the result is 10.
This is a conclusion of the trigonometric problems of the group number 4. The united circle is important because between certain angles inside the circle with a radius of 1 allows special coordinates to be located where the circumference of the line certain by a single angle intersect. Also, the special angles are important because certain angles have values that can be replaced inside of an equation that contain trigonometric functions. The reference angle may be used to obtain the value of the relative angles in a more effective way. The singular angle determined by the quadrant an angle is found on, and whatever trigonometric function as sen or secant. Thank you.